Miracle AluRepairPlus. We present to you in this video our solution to the latest challenges in car body repair when replacing entire aluminum castings, such as in this video on an A-pillar, a suspension strut dome, a roof edge, or a lower beam. Body technicians are then faced with a new challenge since the punch rivets are predominantly lined and so cannot be accessed from behind. Simply drilling out the rivets would create many holes and an incredible amount of cuttings. Considering the large amount of effort required to bore over 70 rivets, the technician is only too aware of the enormous amount of time and costs that result and how much the quality of the repair will also suffer. In the picture you can see how the holes that result when the rivets are removed from the disassembled cast aluminum part are not damaged around their edges. This is also the case for the inner part of the A-pillar. Using the system we have developed to meet these challenges, you will see in the following video how easy and reliable the replacement process can be for such components. The body technician is faced with the same challenges when attaching steel and aluminum ground and fixing bolts of up to 10 mm. We will now show you how to remove rivets quickly and non-destructively by using our Miracle AluRepairPlus system. First, sand down the paintwork on the rivet heads and remove dust from the surface. We can only ensure that the welding process will work properly if the surfaces are clean. Also sand down the place where you want to affix the ground. Then set the power unit to the correct parameters. These depend on the diameter of the bolts and what they are made of, so either steel or aluminum. The diameter and length of the bolts being used and the accessibility of the body also determine which support to use. Now push the stainless steel threaded bolt into the device and position it carefully in the chuck. Position the chuck containing the bolt over the rivet and press the chuck firmly down onto it so that the bolt makes contact with the rivet neatly and with pressure. Now weld the bolt. In the video we can see how the bolt is welded to the rivet. Once the bolt has been welded to the rivet, pull the gun carefully away from the rivet in a vertical direction. Be careful not to break the bolt when removing the gun. At slow motion you can see the high amount of energy used in the welding process to weld the bolt and rivet together. You can also see clearly how the bolt cools down at the edge of the weld. Once the weld has cooled, you can pull out the rivet together with the bolt. We use the Audi special rivet device, the VAS 6792 compact rivet device, with a VAS 6792/2 extension which applies enough power when removing punch rivets in order to remove the rivets from the material in one pull. In the picture you can see the rivets that we have already removed. You can easily see how the bolts are welded securely to the rivets in the process. Similarly, you can see how the rivets have been removed correctly and neatly from the component. Once all of the rivets have been removed, the device support can be removed effortlessly from the lower component. As you can see from the component cavity, there is no damage at the points on the back where the device support had been affixed. You can only see the points where the rivets had been set into the aluminum when the component was produced. Next we will show you how to weld an 8 mm aluminum ground bolt to the component. To do this, we have removed the paintwork and dust from the surface to which we want to weld ground bolts. Adjust the chuck by switching to using the ground bolt attachment. Now set the correct program on the power unit and push the ground bolt into the chuck. Here too, the chuck needs to be positioned with care and apply pressure when welding the ground bolt. At slow motion, you can see the high amount of energy that is required to fix the bolt securely during the process to both thin aluminum sheets and thick-walled cast aluminum parts. The difference between thin aluminum sheets and cast aluminum parts is important to note, since this greatly affects which parameters you select on the power unit. In the picture you can see how the high amount of energy applied to the part has created a neat secure weld at the base of the ground bolt. So that you can see that the weld has the correct strength, we will screw a cap nut onto the bolt and, using a torque wrench set to 25 Nm, will observe at what point the bolt breaks away from the component when torque is applied. You can see that when the torque wrench is turned, the bolt becomes softer above 25 Nm and shears off close to 30 Newton meters. 8mm bolts like this one are tightened on average at a maximum of 20 Newton meters when conducting repairs.